Yeah, I've never once talked to her.
Really? Okay. All right. Hello, people watching this video. This is it says chapter 5 test, but it's just like the final problems that are associated with, oh, there's only 3 pages. That's exciting. Just the final problems for matrices, okay? 2 and 5, they don't even have to do with matrices. They say use substitution elimination. I'm going to do number 5 together with you because they asked for it. So here you go. All right. We need to eliminate a variable. Just one. Which one?
Z's.
I want to eliminate z's. You know how I want to do it? I want to add these 2 equations together to eliminate the z, right? Then I want to add these 2 equations together. You could add the first and third equation together, but then I'd have to like make one negative, right? So I'm going to do the first and second equation added together, and then the second and third equation added together because I don't have to do anything, right? Okay, so if I do that, if I add these first 2 equations together, how many x's do I have? I'm going to put them out over here. 3x, okay, plus 3y. Z's are gone. Equals 6. Perfect, okay? Now, if I add these 2 together, okay, the z's will also cancel out, but how many x's do you have? 4x plus y equals 8. Okay, z's are gone. Now, this is just a 2 by 2, right? Like this is just a regular one. Okay, shall we eliminate? Which one? What? The y's. Okay, let's multiply this guy by -3. So I'm going to do that right here. Negative 12x minus 3y equals like -24. So I'm putting this guy together with this guy. Okay? How many x's will we have? -9x, the y's are gone, equals -18. Boom. X is 2. So now we work backwards, okay? So we go back to any one of these 2 equations right here or right here, and we can plug 2 in for x and solve for y. Then we take that x and y and solve for z in one of the other ones, right? So the second one, this right here, 4x plus y equals 8. Yep. 4x plus y equals 8. X is 2.
So y is 0.
So y is 0 because this is 8, right? If we minus 8, y is 0. Hey, that's okay. So now we plug into any one of these 3. Which one would you like to do?
The top one.
The top one? Sure. So 2x, and x is 2, plus y is 0, plus z equals 3.
You're saying -1.
You betcha. This is 4, right? All together, that's 4. So if I subtract 4, z is -1. So final answer, 2, 0, -1. And that is the solution where all 3 of those, equations are going to cross. Yeah. And that is in 3-dimensional space, actually, by the way, because we have 3 variables. How about that? Good, good? Beautiful. Okay. Do you remember how to do number 6? No, that's why I asked. All right. You use, this is called Gauss-Jordan method, but it is like the reduced row echelon. So we start with our matrix 3, -2, augmented with 13, and then I go 4, -1, augmented with 19. Okay? And this is where I just try to get him to 1, 0, 0, 1, right? And as soon as I do that, as soon as I get the 1, 0, 0, 1, this guy is going to give me my answer. Okay. Should we do this one together as well? Sure. Yeah. Which number do we pick on first? 3. We want to get him to be a 1. How do I do it? Divide by 3. Perfect. See, we're getting better at these. Okay. That bottom row is going to stay 4, -1, 19. He's just chilling. Okay. But the top row, if I change him, he will be 1. -2/3. 13 over 3. That's disgusting, but we'll manage. Okay, now what do we pick on? The 4. The 4 needs to be a 0. So I take top row times -4. All right, so I'm going to take him times -4. Okay, so that will be -4. I just write them up above. -4. What is -4 times 2/3? -2/3.
-8/3.
Should be positive 8/3, right? Positive 8/3. Okay. And then -4 times 13 over 3.
Which would be -52 over 3.
-52 over 3. Ugh. Okay. All right, so top row is gonna stay. Top row stays, 1, negative 2/3, 13/3. Now I add this guy and this guy together. So that will make him 0. Great. 8/3 minus 1. That would be like 8/3 minus 3/3. 5/3. Okay. All right. Negative 52 over 3 plus 19. Okay, 19 in terms of thirds
I got,
is 19 times 3 is 60 minus 57. 57/3. So it's negative 52/3 plus 57/3.
5/3.
5/3. Is that what you got?
Yep.
Yeah, perfect. Okay. It's going to start getting better now. Okay, now what do we pick on?
The
5/3. We want to get him to be 1. So we divide by 5/3 or multiply by 3/5. That will get him to go away. Okay, so again, that top row is going to just chill. He's going to stay 1, negative 2/3, just chilling out.
1, 1.
13/3. And if we multiply by 3/5, 1, 1. Aiden says. Okay, this is going to come out real nice. Now we want this guy to be a 0. So we take the bottom row times positive 2/3, right? Okay, if I do that, that'll be 0. This will be positive 2/3. This will be positive 2/3, right? Okay, bottom row's just going to chill because he's done. The bottom row's done. 0, 1, 1. Okay. The top row, if I add this guy and this guy together, 1 and 0 is 1. 2/3 and negative 2/3 is 0. Hey, what's 13/3 and 2/3?
5. Oh, it's 5.
15/3, which is 5. So now I have my final answer. If I were to have done substitution or elimination, my answer would be 5, comma 1. That's where those two things are going to cross each other. How nice. It's a pain in the butt in the middle, yeah, but the answer's nice. That makes me feel better about, like, that we did it right at the end when I get a nice answer. So, yeah. Okay. Okay, 10 and 11 are determinant. It's the diagonal down minus the diagonal up. So on the 3 by 3, do you remember we like copied these guys down? 0, 7, 5, right? And we did the diagonal downs. You know what I'm talking about? Down and down. Hey, that second diagonal down. He's gonna be 0. It's multiplication, and then you add those together. Then my ups are gonna be this one, and this one, and this one. So yeah, you multiply the elements, but you add them together. You want me to do it, and then you can check? Oh, Lord.
Maybe the one's going.
Okay, I don't think I did this right because I got a really big number.
Hmm.
Like, really big number.
Okay. Holy moly.
Yeah, I think maybe I did do it right.
You
I
did
got
do
a
it right, I
really
bet.
big
I bet you did. Did you get a really big negative number?
Yes. Like, really big. Negative 844.
Yep.
Wait, am I subtracting?
Yes, so you do the diagonal downs, you add those
That's not
together.
a plus, that's a minus.
it should be negative 42
Oh, it's fast.
minus 16.
I thought that last part was a plus.
That's what I got for him. Yep. If you want to, 22, 23, 24, 25, 26 are really easy.
How do we do Kramer's rule?
We'll do Kramer's rule together. Shall we? Are we ready? Kramer's rule? Okay. Kramer's rule says this. Okay. If I want to solve for x and if I want to solve for y, what I do is I take dx and I divide by the determinant, and I take dy and I divide by the determinant. Okay? Now, here's what dx and dy and all the things are. So the normal determinant matrix is just this regular guy right here. 2, negative 3, 4, and 5. Okay? The dx matrix is,
This is the one where you have to eliminate stuff, right?
yeah, so the dx matrix is everything except the x's. The x's would go in this column, but instead of going in that column, what goes in that column? The equal to. Then the y stays the y, right? Okay, so negative 33 goes here, 11 goes here. Yep. And then negative 3 is here and 5 is here. We got to find the determinant here in a second, but we'll do that. Okay, the dy matrix, the y column should normally go in the second spot, but in his place, we're not going to put that y column. We're going to put that equal to column here and the x column here, right? So 2, 4, negative 33, and 11. And now we do all the thingy things, right? Okay? So diagonal down minus the diagonal up. D is going to be, I got 22. Because it's minus a negative 12. Okay? And I think these other numbers are probably going to be bigger numbers as well. So this guy diagonal down, negative 33 times 5.
Negative 165.
Thank you. Negative 165 minus a negative 33. So plus 33 would be negative 132. Okay. This guy, diagonal down, is 22 minus a negative 132. Yep. So I'm going to add those. So that is 154. Those are my d, dx, dy stuff. Okay, so if I'm trying to find the x guy, he will be negative 132 divided by 22, which is, I don't know, something.
Negative 6.
Negative 6, perfect. Okay, and dy, 154 divided by 22, and he is 7? 7. So, final answer? Negative 6 comma 7 is the solution to that. Yeah. Using the determinant. Using the determinant. Okay, was that too fast? Was that okay?
That's good.
Okay. All right, now these bottom guys, these are all addition, subtraction, and all the things, right? Now, make sure it says if possible. What's the rule for adding and subtracting?
Be the same.
They have to be exactly the same size. So 23, are those all exactly the same size? Don't forget you need to multiply by 3 first, right? So this is not 2, this is actually 6. This is actually 9. This is actually negative 12. This is actually 3. This is actually 15. This is actually 27, right? So if you want to change those, get rid of your 3 first, then subtract, okay? You should be the same matrix. 24? You guys are still looking at 23.
No, it's not possible.
24. I can add the first
You can add the
two,
first two, but then you can do
but I can't add the last one, so the whole thing's null and void. Yep.
And we can't do 26.
So, yeah, so 26 is a 2 by 2 times a 3 by 1. Can I multiply them together? Nope. Okay. But I can on 25. 25 is a 2 by 3 times a 3 by 2. Let me not put a
Can we
thing there.
do the X's on 22?
But that's easy.
X is on 22?
Are you just solving for each spot?
Mm-hmm.
Yeah, they gotta be
So
the
like
same
this
spot.
guy has to be equal to this. So 5 equals y minus 2. So y has to be equal to 7. Final answer. Yep.
How do we do that?
I
The
definitely
middle one. So x plus 6 has to be equal to 4 minus x, and I'm going to get the x's together. So let's add the x over. Yeah. So 2x, if I subtract the 6, is negative 2. X is negative 1. Yeah. That's how it has to be in, and then find w. How it has to be when you're setting two things equal. Each cell has to be cell for cell correct. Okay. So then you gotta do 23 and 25. Oh man, we only have not very much. What? Dang, this is exciting. That song stuck in my head. Connor, did you bring me your gown?
No, but
No.
my mom wants to do it.
Oh, she's gonna do it? Okay,
Yep.
that's fine. That's totally fine.
Did you grade those papers in the teal tray yesterday?
I did. Remington's gonna put them in the grade book to next period. So.
I'll find you again.
All my grades should be updated as of like 30 minutes from now, or whatever.
Also, that Cricut connected this event.
Like halfway through your cut, or no?
I think so.
Really?
Yeah. Unless it was done, but I don't think so.
Oh, no, it's not. Neither of our computers are open.
Or is he flashing red?
No,
He's just being.
Blue.
No.
Can you go through?
Yes.
To find the inverse, you just slap the identity matrix on.
Yep.
the
And then you do the reducer echelon stuff.
Okay.
Yep. Yep. Holy moly.
No!
No. You don't have to take it now.
Yeah, we do.
Yeah, we do.
Oh, I thought it was fourth period.
No, it
We
is
have
an
110
hour and
minutes.
110 minutes.
To take it.
Uh-huh.
So we're going into third, because all of us are in third.
And fifth.
Holy
We
moly.
shouldn't need to go into fifth, though. I mean, Eli and Reese will, for sure, but I don't know if all of us will need to go into fifth.
Okay.
We shouldn't take
All right.
3 periods for a single 70 questions.
Yeah. Okay. What we don't have done on this, we'll finish on Monday, and then that'll be. I guess we have Tuesday yet in this class too, right? So you have 2 more days of me. So we'll finish this on Monday, and then we'll check in stuff, and then Tuesday will just be chill.
You're making us find 3 inverses.
Just 2. Just 2 inverses.
Okay, Ellie.
No, stop.
What?
I'm gonna cry.
Ellie, it's not gonna be that bad. Don't cry.
Photo memory
Okay.
in. Go.